everybody, this is Miss Kennedy, and we are going to continue talking about ratios. Earlier we talked about ratios as you're comparing two parts of a whole number, or you can be comparing a part to a whole, or a whole to a part. Today we're going to be building onto that and come up with a third way to write ratios. So we are familiar with the 2:3. We learned that the first day. We know that it's also 2 to 3. But today we're going to be talking about how to write it into a fraction. So let's go ahead and get started. The first thing we're going to do, I want you guys to watch this video and take notes of important information. It might take you a second to copy down all the notes, so just pause whenever you think you need to catch up a little bit, okay? Might take a second to load. Oh, there it goes. Okay, let's try again.
Two ratios are equal if the fractions representing them are equal. So to determine whether the ratios 9 to 12 and 21 to 28 are equal, let's first rewrite the ratio 9 to 12 as the fraction 9 over 12.
By the way, guys, you are copying this in your notebook, so you want to copy down to determine whether the following ratios are equal, 9 to 12 and 21 over 28. Okay? Clear. Go.
Now we have fractions representing both of our ratios, 9 over 12 and 21 over 28. To determine whether these fractions are equal, we write each fraction in lowest terms. So dividing the numerator and denominator of 9 over 12 by 3, we get the equivalent fraction 3/4, which is in lowest terms. And dividing the numerator and denominator of 21 over 28 by 7, we get the equivalent fraction 3/4, which is in lowest terms. Since 3/4 equals 3/4, we know that the ratios 9 to 12 and 21 to 28 must be equal.
Okay, good job. So make sure you go back and pause it over here. I want you to make sure you have all this information neatly put in your notebook. You can draw a text box around what you just wrote down, or you can draw a line beneath it to separate it from the next stuff, okay? Once you think you got everything down, push play and we'll move on. All right, the next thing I want you guys to copy down into your notes is this right here. We're going to write two different ratios that are equivalent to 10 over 25, okay? That's the same as saying 10 to 25 or 10:25, okay? Answers may vary. Samples are given. So here are a couple of samples on how to find two equivalent ratios. If you multiply by 2 so that you can find the product using mental math, so if you have 10 over 25 and you're trying to find an equivalent ratio that was a little bit with larger numbers, you can multiply 10 over 25 times 2. You multiply the top times 2, which will give you 20, and the denominator by 2, which will give you 50. All right, you don't always have to multiply times 2. You can multiply times 3, times 5, times 30,000. It doesn't really matter as long as you're multiplying your numerator and denominator by the same value. Now, this is kind of the same thing with division. 10 over 25. Well, they're both, 10 and 25 are both divisible by 5. Again, if you're going to divide the numerator by 5, you have to do the same thing to the denominator. Now, 10 and 25 do not have a common factor that is a whole number besides 5, so you're kind of limited on the smaller numbers, okay? So, two ratios that are equivalent to 10 to 25 are 20 to 50 and 2 to 5. All right, make sure you get all this stuff down, please. Okay, I want you to try to answer this problem by yourself, and when you think you figured it out, push play and reveal the answer, okay? We're going to write two different ratios that are equivalent to 6 over 8, or in other words, 6 to 8. All right, if you feel comfortable using your chart, you can. If you want to multiply, you can, or if you want to divide, you can. Make sure that whatever you do to your numerator you do the same thing to your denominator. Okay? So pause the video and see if you can figure out how to solve this problem. Alright, here's the solution to the problem that we just solved. Multiply or divide the numerator and the denominator by the same non-zero number. Obviously, if you multiply it times 0, you're going to get 0, and that really won't be an equivalent ratio. So you can divide 6/8 by 2, or you can multiply 6/8 by 2. You can also multiply 6/8 times really any value as long as your numerator and denominator are the same. Like your multiples are the same, like this. Sorry, not numerator and denominator. Okay? For division, again, you're kind of limited because 2 is the only number that can go into 6 and 8 evenly if that is a whole number. Okay? So make sure you get all this information down before you push play. Alright guys, the video is going to be kind of short today. So most of it is just a few problems to work out and practice because we already know the gist of what we're doing for the past 2 videos. So let's keep going. I want you to write the ratio 12 to 40 in its simplest form. Simplest form. Now what does it mean by simplest form? Well, if you're making 12 to 40 simpler, you're probably not going to make it any larger. Okay? So this right here is one of those situations where you're going to really have to think about what the language is saying, what the words are saying. When you think you found your answer, push play. Alright. Check your answer. First, write the ratio as a fraction. 12 over 40. The greatest common factor of 12 and 40 is 4, because again, you're trying to simplify your answer. Simplify, divide the numerator and the denominator by the GCF. So in return, you'll end up with 3/10, or 3 to 10 as your simplest form. Okay? And guys, if you are on the digits assignment and you get kind of lost, feel free to rewatch this part of the video or come to the slides, that way you don't get stuck. Okay? Alright, how can you determine whether a ratio is in simplest form? I want you to copy that question down into your notebook. Make sure after you copy the question down that you leave some space so that way you can formulate an answer. Okay? Take your time, really think about a good 6th grade answer that's going to give you a good response. And then when you think you got a really good one, check with the teacher and see if your answer is correct. Pause the video and push play when you think you've got it. Alright, if you kind of got stuck and you weren't quite sure how to make something in its simplest form, I want you to put this right here in your own words. What you need to do is find the greatest common factor of the 2 terms of the ratio. Now stop for a second. What if our ratio was 15 to 25? Okay? The first step is to find the greatest common factor of the 2 terms of the ratio. What is the greatest common factor of 15 to 25? Well, the GCF is 5. So if you were to divide both values by 5, you should get 3/5. Alright? Now let's keep reading. If the greatest common factor is 1, that means if 1 is the biggest number that can go into your fraction, then the ratio is in simplest form. So let's say that our original fraction was 2/3. The greatest common factor of 2 and 3 is 1. Nothing can go into 2 and 3 as a whole number except for 1. So 2/3 is in simplest form. Okay? Ms. Carpenter also put a picture over here on the side as an example, in case you want to look at that as well. We have 4/6. Simplest form is 2/3. Alright, complete the close and check for 2-4, and then complete this homework 2-4. So your teacher will have your close and check on the board for you so you know what to do. Alright, like I said, it was going to be a little bit of a shorter video today, but hopefully you guys kind of understand what to do, and I hope you do well on your digits, and I hope you have a wonderful afternoon. See you later.